Good evening, everyone. So today let's talk about cyclones and their dynamics. So basically, what I'm going to cover in this video is how cyclones form and how they behave. Uh, so I'm not going to talk about the upcoming cyclone that weather bloggers and other weather agencies are talking about. This system, which is supposed to form around May 1st or 2nd. I'm not going to talk about that, but I'm going to explain why it is very difficult as of now to clearly say why this cyclone may or may not form. Okay, and why different models are behaving differently. Okay, so this is more like a educational video. So let's just get started. All right. So before we get any further, so I just want to get the basics right. So basically, there are two different types of pressure systems. One is low pressure, and another is high pressure, as you all know. On the left here is the low pressure system. So this basically means that there is going to be a low pressure in the center, and it is going to be surrounded by high pressure in the outer region, and that is going to push the winds towards the low pressure region, and that's how the convergence happens. So low pressure systems cause convergence, as we all know. They bring the winds towards the center. Thereby cloudy conditions are possible. On the other hand, high pressure systems are one where the high pressure is in the center and it is surrounded by low pressure. So the high pressure will push the winds outside. So that is called divergence, and divergence usually brings hot and humid weather with it. All right. Okay. So with this premise, let us move forward and let us just take a look at what are the things needed for a cyclone to form. So basically, what you all need, I mean, I'm sure you know this. You know, you need a high sea surface temperature, which is should be greater than 27 degrees Celsius. So this is the temperature on the surface of the ocean. That is one of the triggers. Then you have the effect of Coriolis force. So the how the cyclone system will get deflected in the northern hemisphere, how much to the right it will get deflected, will be governed by this Coriolis force, which acts on the synoptic system. Synoptic systems are those which are more than 500 kilometers in span-wise direction. So cyclone does fit this bill. So this will be definitely affected by Coriolis. Then you have a low pressure center. The low pressure center is required, as we talked in the previous slide. The low pressure center is required so that it can pull the winds towards the center, and thereby it can lead to a nice convection and hence cloud formation. That is very important for any uh, system which is low pressure, well marked low pressure, depression, or cyclone. This convection in the center is a very key aspect. Then you need then we are talking about wind shear. Wind shear should be low so that it doesn't disorganize the system. And wind shear is generally taken at, between the 200 millibar level where the winds are strong and 850 millibar level winds are weak. So these are the two levels at which wind shears, two levels which are used for measuring the wind shear. So obviously, we all know that in for Indian Ocean, at least North Indian Ocean, the cyclone season is pre-monsoon and post-monsoon, which is April, May, and October, November are the four major cyclone months. And the reason is very clear because during monsoon months, the wind shear is very high because the low level winds are westerly and high level winds are easterly. So there is a high wind shear which doesn't allow the systems to form, cyclone systems to form. Depression is different, so we're not going to cover depression. Depressions can still form during any of the months in the year, but cyclones are very specific because you need very low wind shear so that the system can retain its shape, and that's how it can pack in a lot of energy. And then the presence of high pressure envelopes or ridges, which allows which kind of acts as the hindrance for the movement. So it will not allow the cyclone to penetrate it. So what the cyclone does is it will just move along the lines of the ridges. Okay. Or any other phenomenon like western disturbance and ITCZ movement, which will not allow the cyclone to move away from its track. So the ridges will basically govern how the cyclone moves. Of course, along with the Coriolis force, because the Coriolis force can deflect it to the right. And finally, upper level steering winds, usually at 500 millibar or high, so depending on the cyclone intensity. So that is the other important aspect. So as you are closer to the equator, the cyclones will move towards the west, and as the cyclone climbs northward, it will start moving towards the west because of the westerly winds. So that is very clear. I think we know how near the equator winds are easterlies, and uh, near 30 degree or 20 degree, 30 degree latitude, the upper level winds are westerly. So that's how the cyclone will start moving towards the east, and then it will, if it is gaining northward latitude, then it will start curving towards the west, sorry, east. Okay, so because of the westerly wind motion. Anyway, so let us just look at the anatomy. This is a figure that I have picked up from internet encyclopedia. So very clearly it shows how the cyclone forms. Basically, where the low pressure is, so this is where the low pressure will be 990 millibars, or if it is much lower, then the cyclone strength will be lower. One of the ways to measure cyclone strength apart from the wind speed is the how much central pressure has dropped to what value. That's how you classify it as so cyclone, severe cyclone, very severe cyclone, or extremely severe cyclone, or super cyclone. So this eye of the this is where the lowest pressure will lie. Okay, so all the winds will come converge, and as the winds come and converge, obviously the sea surface temperature is going to be the trigger. So if the sea surface temperature is high, it will cause the convection, and it will allow all the winds to come here, and as it is convecting, it will take in moisture because ocean is hot, so it will evaporate and give moisture, and that's how the upward draft will start. Okay, so this is how the eye of the cyclone starts forming, and then as it starts to form, it gains vertical altitude, so this will keep moving upwards, 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 and at some point the energy will be lost, or basically it will not have as much energy to move upwards, so then it will start spreading outward. Okay, so the outward spreading usually happens at around 500 millibar, or which is 5 kilometers from the bottom, or sometimes if it's a very severe cyclone or very severe cyclone, then it can this outward motion can happen at all the way to 8 kilometers as well. Okay, which is around 300 millibar level. So what we are seeing is there is the winds which are curving at lower levels. The winds are spiraling inwards, and at the upper level, winds are spiraling outwards. So this is the convergence, low level convergence, and upper level divergence. Upper level divergence is important because if winds don't diverge out, then from the law of continuity or mass conservation, things cannot move in. Right? As long as I don't, as long as I am taking things out, there is enough room for things to move in. So that is how this cyclone is sustained. So this upper level divergence, which happens at 500 millibar or 300 millibar level, is very, very crucial, because if the winds don't push out, then we cannot have any winds which are moving in. Okay, so this is one thing. And then we all know, although the eye of the cyclone is very energy, in the sense that that's where the action starts, and that's where the lowest pressure exists. But we all know that eye of the cyclone is calm. Why? What is the reason for that? The reason is very simple. So what happens is there is the wind. Sorry. So let us look at this. So the winds. So the air moves up, and as the air moves up, then it starts moving outwards, right, at the upper level. That's what we discussed just now. As it moves up, it condenses, as you all know, and it also cools. Correct? So there is this warm air, which is the heat engine for the cyclone. It moves up, and then as it is moving upward, 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 it condenses and it cools because it is moving vertically upwards. Pressure is dropping, so temperature is also going to drop for that particular air parcel. So what happens is it kind of goes outwards, and then since it's a colder air, it will try to drop down. So at the eye of the cyclone, the convection is happening in the outer edge of the eye, and then there is descent. There is the downdraft or the descending pattern of air which is happening at the middle, okay, near the eye, because the cooler upper level air will try to come down. Okay, so that is why the eye of the cyclone is very calm, because there is as such nothing happening here, and it's just one zone of silence. Okay, where this only the cold air is descending down, and this cycle will keep continuing. So this will move up, and then it will move down. Also similarly on this side of the cyclone, move up and move down. So that's why eye of the cyclone will be very, very calm. But nevertheless, the pressure will be very low at the eye, because that's where the convergence will start happening. Okay, and this downdraft of this cold air will happen periodically as shown here. So there will be updraft followed by a downdraft, updraft followed by a downdraft, and so on and so forth. This is just a schematic, so it doesn't have to happen in this such an organized manner. It could very well happen in a very irregular pattern, except for the eye of the cyclone, where this will definitely happen. Outer in the eye wall, so this region is called the eye wall, where cloud band starts to form. This region, there can be updraft, and then a massive downdraft, and then updraft, and a massive downdraft. So, but nevertheless, this is how the updraft and downdraft patterns occur, and that's how the rain bands also start forming, and that's exactly how the entire cyclone starts to get the shape, or they get the structure. And one of the main one of the main points to get the structure is the convection, the heat energy, or the heat engine that we talked about, or the moisture that is coming from the ocean. If the ocean is very hot, obviously the convection is going to be very, very strong, and it's going to pick up a lot of moisture, and there is a high chance of a cyclone to form. If the wind shear is also very low, then those two things are going to be the key parameters for a cyclone to form. Okay, so this is how the anatomy of a cyclone looks. There is eye wall, and there's eye wall. There's something also known as eye wall replacement. So that is a very tricky thing. The eye wall replacement is nothing but so some part of this wall is going to degenerate, and then it is again it's going to again start forming. Okay, that is what is known as eye wall replacement. So this is not a very well understood process, because sometimes what happens is the cyclone may lose its energy by doing this eye wall replacement, but sometimes there is a re-energization, because the second eye wall that forms could be stronger than the first eye wall because of rapid intensification. So how it works is not very clear, but there is also known as sometimes a cyclone loses its energy as it comes towards the coast. That's kind of attributed to the replacement cycle, or sometimes it gains energy, which is also attributed to a replacement cycle. So I think one of the important parameters is where the eye wall replacement occurs. If it happens closer to the coast, then the intensity will be lower, the cyclone intensity. But if it happens in the open ocean, then there is enough time for the eye wall to form again, and it can re-intensify and intensify much more than the previous cycle. Okay, so that is how I perceive this process. Like I said, it's a very complicated process. But it happens. I mean, people have observed that in cyclones. All right. Anyway, so let's move ahead. So knowing this, let us just now understand what is expected. So like I said, I'm not going to talk about the cyclone that is being expected in end of this month or starting of May, but I'm just going to tell you why at this point of time it is very difficult to predict a cyclone, and why models are not converging onto one particular track. Okay, let it be European model or German model or US or even our Indian model, why they are all giving different results. Okay, so there's one very important aspect, which is ITCZ, or the Hadley cell movement. So right now, as we all know, ITCZ keeps moving south and north. Right now is the time when it is going to move north. So right now it's near the equator, and it is slowly starting its northward journey. So this is the ITCZ, where what happens in ITCZ is the winds from the northern hemisphere and the southern hemisphere meet, and they converge. And since they have nowhere else to go, they move upwards. And again, this is a